To chapter 9.2, naming and writing formulas for ionic compound. Okay, so first thing we're gonna learn how to write the formula for binary ionic compounds. We already done this sort of in chapter 7. So I'm gonna sort of review chapter 7 but go into more detail here. All right, the main concept for this is to write the formula of a binary ionic compound. First, write the symbol of the cation and the anion. Then add the subscript as needed to balance the charges. And I'm going to provide you with few examples here. So the first example is potassium chloride. Okay, in order to, we're going to write the symbols first. So the symbol for potassium is right here, K, and keep in mind K has a positive charge, and the second one is chloride. The symbol for chloride is Cl, and it has 1 minus charge. So I'm going to write the symbols right here. So potassium, the symbol is K, and it has a positive charge. Chloride is Cl, and it has a negative charge. And keep in mind that ionic compounds have to be neutral. Okay, that means the charge has to be 0. Okay, so let's see. Does one positive cancel out one negative? Yes. Do we have to add any subscript since it's already balanced? No. So the formula is just KCl. Let's do calcium bromide. Okay, if we look at the periodic table, the symbol for calcium is Ca, and bromide is Br. Now calcium has a 2 plus charge, bromide has a 1 minus charge. So I'm going to write the charges here, Ca, Br. I'm going to write the symbols first. So calcium has a 2 positive charge, bromide has 1 negative charge. So how many calciums and bromides do I need? What's going to be the ratio here? Well, I need one more bromide to cancel out the 2 positive charge. So I'm going to write another bromide, which is 1 minus. So 1 minus plus 1 minus is 2 negative. 2 negative will cancel out 2 positive. So I have Ca 1 to 2 ratio. So I have 1 calcium. I don't have to write 1 subscript. And I have to have 2 bromides to cancel out the 1 calcium. So it's CaBr2. Let's look at the next example, iron 3 oxide. Now, iron can have various charges. Iron, if we look at the periodic table, can have a 3 plus charge, 2 plus charge, and I think I even saw one with a 1 plus charge. So iron can have several charges because it's a monatomic transitional metal. So this Roman numeral, iron 3, tells us the charge of this iron is 3 plus. Oxygen is right here, so it's 2 minus. I'm going to write 2 minus. So let's write the symbols. The symbol for iron is Fe. The symbol for oxygen is O. So I'm going to write FeO. Now we have to make sure it's balanced. So there's also a crisscross method where you can bring the 3 plus over to the oxygen and 2 over to iron. And that's going to balance out the equation as well. But let's look at right here. I have Fe 3 plus and O 2 minus. So the common denominator where 3 and 2 will divide, well, the common neutral charge between them two has to be 6. So I have to have a 6 positive here and 6 negative here. So I'm going to add another Fe3 plus, another O2 minus, and another O2 minus. So in order to balance out the charges, 6 plus cancels out 6 negative. I have to have 2 to 3 ratio, which I have to have 2 irons and 3 oxygens. So the formula for iron 3 oxide is going to be Fe2O3. And double check, 2 times 3 positive is 6 plus, 3 times 2 negative is 6 minus. 6 plus cancels out 6 minus. Let's do the next one, calcium sulfide. So calcium has a charge of, the symbol is Ca, 2 plus, and then sulfide is sulfur, so sulfide is S2 minus. Okay, so I'm going to write the symbols here, CaS. Calcium has a 2 positive charge, sulfide has a 2 negative charge. Does these charges balance each other out? Yes, they do. So do I need to add any subscripts? No. 2 positive cancels out 2 negative, so it's just CaS. Let's look at this one, copper 2. Well, what's the charge of this copper? The Roman numeral 2 says that it's going to be 2 positive. Sulfide is in group 16, so group 16 elements have 2 negative charge. So 2 positive and 2 negative. Do these charges already balance out to 0? Yes, they do. So the symbol for copper is Cu. The symbol for sulfide is S. And since these balance each other out, it's just CuS, 1-to-1 ratio. Okay, let's look at the next one. Potassium. Potassium is in group 1. The symbol is K, 1 positive. And the next one is nitride. Nitride is in group 15. It has a 3 minus charge. So I'm going to write the symbol. The symbol for potassium is K. And the symbol for nitrogen, which becomes nitride, is N. Potassium has a 1 plus charge. Nitride has a 3 minus charge. Okay, we can all use the crisscross method. So we're going to have 3 potassiums and 1 nitride. But let me go on the side over here and show you that the charges need to equal. So since I have a 3 negative here, I need 3 positive for the cations. So how can we get to 3 positive if every single potassium ion has a 1 positive charge? Well, we're going to have 3 potassium ions. 1 plus 1 plus 1 is 3 plus, and we just need 1 nitrogen, which has 3 minus. 3 plus cancels out 3 minus. Okay, so we're going to have K3N as our formula. Okay, any questions? All right, well, I guess you guys can't answer. Sodium iodide. If you have any questions, just send me a message for a model of Microsoft Teams. Let's do sodium iodide. Sodium has a 1 positive charge, and iodide has 1 negative charge. So sodium, the iodide has an I symbol, and sodium has Na symbol. So I'm going to write the symbols first, because that's the rule. So sodium is Na, iodide is I, and sodium has a 1 plus, iodide has 1 minus. We can use the crisscross method, so it's 1-to-1 ratio. So Na plus, and then I minus. So 1 plus cancels out 1 negative. So we only gonna need a 1-to-1 ratio here, 1-to-1. So NaI, we don't need to add any subscripts. Let's do potassium. Remember, potassium had a 1 plus charge if we look at the periodic table. Sulfide had a 2 minus charge. The symbol for potassium on the periodic table is K. The symbol for sulfide is S. And we can also use the crisscross method. So sulfide, we have to have 1 sulfide and 2 potassium. So let's do this over here. K plus, S2 minus. So we need a 2 plus here, 2 minus here. So we need to add another potassium. So we have 2 potassiums for every 1 sulfide. So it's 2-to-1 ratio. So it's going to be K to K, K2S. Okay. Okay.